In this video, we will show the Specs secure storage application used by E2EE, a cloud storage provider. Before any cloud resources are acquired and services are set up, the customer, Alice, has to negotiate the security level of the desired service with the help of the negotiation wizard. First, Alice selects the right service. For the chosen secure storage service, Alice is offered security capabilities that can be implemented by Specs. In the next step, Alice negotiates security controls that Specs is able to enforce with its security mechanisms. Specs uses security control frameworks introduced by NIST and Cloud Security Alliance. Alice also has an option to declare how important each chosen security control is by specifying the importance weight. Based on a set of chosen security controls, Alice is offered a set of security metrics to be enforced and monitored by Specs. Alice selects the desired security metrics, specifies preferred values and importance weights. These preferences will be defined as service level objectives in the service level agreement offered to Alice. When Alice requests offers, Specs verifies whether the requirement can actually be implemented and prepares a set of service level agreements, one for each cloud service provider. Offers are ranked and presented to Alice. Alice can check each offer and submit the preferred one. The negotiation process finishes with Alice signing the service level agreement and triggering the implementation process. Specs acquires external resources and deploys two security mechanisms that are needed to enforce the service level agreement negotiated by Alice. The first mechanism, database and backup, supplies storage components, such as servers and databases. The second mechanism, end-to-end encryption, enforces local encryption on Alice's infrastructure. When the service level agreement is enforced, Alice is provided with a client component. She installs it, logs in, and registers the server by which all the storage data is managed and the auditor which monitors write serializability and read freshness. After registration, the secure storage service is ready to be used by Alice and her SLA is monitored. Alice can now start encrypting files and storing them in the cloud. Alice simply takes a file and drops it in the encryption box. The client component encrypts it locally in the browser and sends the encrypted files to the server. Alice wants to share a file with Bob, so she asks him to install the client component and register secure storage components. Bob registers components, logs in, and adds Alice as a trusted user. Alice logs in and adds Bob as a trusted user. Now, Alice is ready to securely share files with Bob. Right after Alice selects the file to be shared with Bob, she updates it. Note that now there are two versions of this file saved in the database. We simulate an event where the attacker gets control of the server and forces it to start responding to all download requests with old versions of files. This is the so-called rollback attack. Bob logs in and tries to download the shared file. Specs detects that the server tried to return the older versions of the file and notifies Bob. Alice's service level agreement is violated. Specs analyzes the violation, identifies the attack, and rules out a system error. A remediation plan is identified. Server and database are removed and replaced. New resources are acquired and new components are deployed. The violation is resolved and Bob is notified. New registration information is provided and Bob has to register new components. After reconfiguration, Bob logs in and tries to download the file again. This time, download and decryption are successful. The SLA continues to be monitored, and Alice and Bob can safely use the secure storage service.